Okay, so today we will see some things about awk. Awk is in fact something like a programming language that we can use directly on the terminal, and quite often it's useful to format files, read files and take some specific fields or output from this file. For demonstration reasons I have prepared a microarray file, so some expression levels for some genes. Let's have a look on this file. So it's called microarrays100.soft. This file contains 100 lines and in fact 99 expression levels for 99 genes. Okay, if we have a look on that. So the first row is header row, and then we have recordings for all these genes, one gene on every row, and in columns we have different persons, so different patients. The first column is an identifier for the probe, so it's a probe ID used to measure expression levels, and the second column is the name of the gene. So for this MIRS 4640 we have the expression level 1124 for the first sample, and so on. Now this file is nicely formatted in columns like a table, and therefore it's pretty easy to work with awk, but also with other programming languages like R or Python or Perl. Okay, let's start with awk. We can either use awk directly on the command line or write a script and call awk from the script. We'll see first in the command line, and then we will write the scripts on. We will write the code on the script. If we just want to print out the file, then we can just type print and the name of the file. So in fact awk can read from the standard input, therefore another way is this one. It will do exactly the same thing. Or another way will be this one. So another way, awk can read from the standard input, so we can use this redirect character to read the file, or we can read this file with cat, for example, and then send everything to awk. It will be exactly the same. Now, of course, it doesn't make so much sense just to print out the file because we can directly use cat for that. But now we can use awk to print some parts of the file. For example, if I go just to print out the probe IDs, I will use the field symbol 1 to the number of the column. So awk by default understands this white space here, and the different columns are called fields, so it can be used to print out specific fields. If I just want to print out the first field, which is the probe ID, I will use print $1. If I want to print out the second field, which is the gene name, it will be this one. If I want to print out the first and the second, then I can use $1, $2, and I can put a separator in between, like a comma value or a tab value or just a space. Of course the tab is suggested because it formats everything better. Of course, the delimiters can be combined, so if I want then to print the third column with a comma, I can just use a comma here, and so on. awk also contains some special variables that can be used directly to print out things. So, for example, if I just want to print out the last column, so the last field, then either I have to go to the file and measure how many lines I have and use this number, or I can use the nf variable. This will print out the last column. Now I think that it also contains nr, which is the number of rows. Let's see what this will do. So if I use the nr without $sign here, it will just print out the line or record numbers. So if I just want to print out the row numbers next to the lines, I will use the tab and then the $0, which refers to the whole line. And you see here in the beginning of every row there is its number. You can do that, of course, with the first column to be more visible. Now we have row numbers next to the probe IDs. So we can mention also that awk processes the file line by line. So for example, if I use the nf here instead of the $nf, which is the value of the last column, and nf is the last column, the number of the last column, so this will just print out how many columns each row contains. So let's see that. If I print out, if I will use nr comma nf, it will inform us that every row actually has 81 columns here. Now this is an easy way to check, for example, if the file is properly formatted to read it in R. For example, I can just print out the number of columns, number of fields, and then sort and use unique. So the output of awk, of course, can be passed to other software like sort or unique or whatever. And we'll just say here that all rows contain 81 fields, which means that it's a proper table, and I can read it, for example, with read table in R and so on. Now we can use awk to extract also some lines that have a specific pattern. For example, let's suppose that we are looking for lines, for records, that refer to the gene PRR22. So I can use awk to search for the pattern PRR22. So we can use the two slashes and inside there put the pattern that we are searching for. PRR22, if I'm not mistaken, print, and this will print okay, this is a mistake. Let's see. Yeah. It should be here. So it found out two lines. One is this one with this 7180 probe, and the other one is this with the 7280 probe. Both of these probes refer to the same gene, so these are probes that hybridization happens on the same gene. Now we can do more advanced things. We can, for example, print out, let's suppose that we want to find out how many genes are expressed above a level in the first patient. So the idea here is to use the if conditional, and if the expression level in the first column, in the first record, the first individual is greater than a certain value, then we can print out this value or print out the whole line. Okay, let's see how to do that. So the first record is on the third column of the file, because the first two rows refer to the probe ID and the gene ID respectively. So if 3 greater, let's say, than the value 10, then print let's print the name of the gene, the name of the probe and the name of the gene. And let's put the value, let's print out the value also. So field number 1 is a probe ID, field number 2 is a gene ID, and field number 3 is expression level of the first gene. And indeed, as you see, all of these expression levels are above 10. If we want to measure them, to count them, to see how many they are, we can use WC-L on this output to count how many lines we have. So out of 99 genes, 85, the expression level of 85 is greater than 10 for the first individual. Now let's suppose that we want to find out how many genes, for how many genes the expression level in the first and second individual is greater than, let's say, 100. So we can do mathematical operations between the fields, and then let's print also the fourth column here. And remove this WC-L to see the expression levels. Okay. So we see here, for example, that summing up these two numbers, always they will be above 100. We want to measure them, to count them, how many they are. Just 38. Okay, let's see the following. If we want to find out for how many genes the expression level on the first patient is greater than the expression level for the second patient. Let's print them first. So now the only thing that I did is that I use if here and say, okay, the third field should be greater than the fourth field. And if this condition is satisfied, then print the first, the second, the third, and the fourth column. And indeed, this expression level should be always greater than this expression level. And these are 47 probes. Let's see if division works. So let's do the following. If the ratio of the expression levels between the first and third patient, so column 3 and 5, is greater than, is less than 0.4, which means that the expression level of the first individual should be less than 40% of the expression level of the second individual, of the third individual, sorry. Okay. Okay, this will not work probably because this will be an integer. Or it will, yeah, let's find out why this is not working. Okay, the reason is that if we see the file, it contains here the row line. Okay, let's see it with less minuses. Now, using awk, we process also the first line, which contains no numbers here. And these numbers are interpreted as these phrases here, the IDs of the samples, are interpreted as 0, and therefore it does 0 division, and it reports an error. So what I did to escape this problem, I put a pseudo count on the denominator here, 0.001, okay, even a smaller number, and because there are no genes actually that the ratio of the in the first and the third patient is less than 0.4, I make this number a bit larger, so 0.8. So this means that the expression level in the first individual should be less than 80% of the expression level of the third individual. And indeed it finds these genes. 72 to 93 should be less than 0.8, 16 to 20 should be less than 0.8, 12 to 13 should be less than 0.8, and so on. No, yeah, here we should print out 5. Okay. Yeah, 3 and 5. The first and the third patient. Because 12 and 13 should not be less than 0.8. So it's 12 to 15 here, 115 to 183, 213 to 333, and so on. Okay. Now awk, with awk we are able also to change the delimiter. I said in the beginning that the default one is any white space, but we can use other delimiters as well. So let's see this file. This is a file the same as the previous one, but instead of tab separated values, we have comma separated values. Therefore, if I would use awk, for example, for the last experiment, this will not work. Oh, it automatically, no, yeah, it will not work because I must change this one. So it cannot separate the different fields. I can change, however, the default separator using the -F flag, and then specify here that the separator is a comma. And now it will work as previously. Okay, and the last thing that we will see with awk is how to pass external variables. Now let's bring again the previous example, which prints out the expression levels of the genes that the ratio between the first and the third patient is less than 0.8. And let's suppose that we want to pass an external variable called v1, which will have the value 3. So v1 will be 3, and we're going to pass this value v1 within the awk code, within the awk script, and sum this value of v1 to the expression level of the first gene, of the first patient. So we would like to write here v1. Now this will not work. We need to use here the variable, the flag v, and say that, okay, let's use the number v here, v equals to the value of v1. Oh, if I haven't done a mistake, this should work. Let's put a parenthesis here. Okay, now this will find maybe no gene. Let's see what the output will be. Okay, now you see that less genes have been printed out. There should be 5 here, because we refer to the first and third patient. And yeah, so this will be 16 plus 3, 19, and 19 to 25 should be less than 0.8, and so on for all the rest of the genes. If, for example, if I will do this -1, then it will print out more genes, of course, and if I will do this 0, it will print out the original list. Again, I mention here the flag -v. Then we use a variable name here, whatever we want, my var, for example, and then $v1 refers to this variable. So my var gets the value of v1, and then here we use this variable without $sign as we want. And that's it for now. Thank you.